In this video, I'll consider one example on waveform synthesis. Find Laplace transform of the waveform shown below. This is given waveform f of t. We need to calculate Laplace transform of this waveform. So here we can observe that at t equal to 0, there is one ramp signal. This is the ramp signal which begins at t equal to 0. So my first signal must be ramp signal. So when ramp signal we consider, we must calculate slope of ramp. So here the coordinates are x1, y1, values are 0, 0, and at this point the values are x2, y2, x2 is 1, y2 is 3. So slope can be calculated as slope is equal to y2 minus y1 divided by x2 minus x1, that is y2 is 3 minus 0, x2 is 1 minus 0, that is equal to 3. So let me draw the ramp signal, which is my f1 of t, that is, so this is say f1 of t, it's a ramp signal of slope 3. So I can write f1 of t is equal to 3 r of t, or I can write 3t u of t. So now here we can observe that this ramp signal is stopped at t equal to 1. So we must, this will continue till infinity. It must be stopped at t equal to 1. So to stop this ramp signal at t equal to 1, we must add one negative ramp signal at t equal to 1. That is, like this, we have to add one negative ramp signal at t equal to 1. Let that be my f2 of t. So I can draw f2 of t as, say this is f2 of t. So at t equal to 1, we should add one negative ramp of slope 3. So it will be like this. So I can write f2 of t is equal to, slope is 3. It begins at t equal to 1, that is r of, slope is minus 3, r of t minus 1, that is nothing but minus 3 t minus 1. We have u of t minus 1. So now upon adding f1 of t with f2 of t, the resultant signal looks like this. I'll show here. It will be like this. And when we add a positive ramp and negative ramp here, the resultant signal will be like this. So now here we can observe that again at t equal to 1, this signal has dropped down to 2. Here the magnitude is 3. It will come down to 2. So we should bring this step signal to 2. We should add one. Here it is 3. To make it 2, we have to add minus 1. So we have to add one negative step signal at t equal to 1. Let that be f3 of t. So that is, say this is f3 of t. We must add at t equal to 1 one negative step signal of magnitude minus 1. So this will be minus 1. So I can represent f3 of t is equal to, we have minus 1, that is minus u of t minus 1. So now upon adding f1 of t, f1 of t, f2 of t, f3 of t, thus the resultant signal will be like this. I'll show here, and it will come down and it will continue till infinity. This is the resultant signal after adding first 3 signals. Now here we can observe that at t equal to 2, we must stop this signal. So at t equal to 2, so here we can observe that at t equal to 2, the magnitude of signal becomes 0. It means at t equal to 2, we need to add minus 2 negative step signal of magnitude minus 2, so that plus 2 and minus 2 will become 0. Let that be my f4 of t. That is, let me draw here. Say this is f4 of t, that is at t equal to 2, we must add one negative step signal of magnitude minus 2. So I can write f4 of t is equal to minus 2 u of t minus 2. So now upon adding f1 of t, f2 of t, f3 of t, f4 of t, so this value will become, this will become the f of t. This is the original signal, which is decomposed into 4 signals, f1 of t, f2 of t, f3 of t and f4 of t. Therefore now I can write f of t is equal to f1 of t plus f2 of t plus f3 of t plus f4 of t, or I can write f1 of t is 3tu of t, 3tu of t, f2 of t is minus 3t minus 1 u of t minus 1, f3 of t is minus u of t minus 1, f4 of t is minus 2u of t minus 2. So now taking Laplace transform of this expression, that is taking Laplace transform of f of t, we get, so Laplace transform of f of t is f of s is equal to 3tu of t is 3 by s square minus 3 by s square e power minus s. Here we have step signal, that is minus 1 by s shifted by 1 unit minus s. This is also step signal shifted by 2 unit, that is minus 2 by s e power minus 2s. So this is the Laplace transform of given waveform. Thank you for watching.